This is Physics 1 course. In this video I will solve another example on constant acceleration motion. A car moves at a constant acceleration of 3 meters per second square in the x direction. If it is at the origin when time is 0, when it is still at rest, find its location when its velocity is 4 meters per second. Let's see what is provided and what is asked. So first of all, it's moving at a constant acceleration of 3. So let's say I have A equals 3 meters per second square, and then it's in the x direction, so it's ax. If it is at the origin when time is 0, so at time t equals 0, x, at time t equals 0 is at the origin, that means x is also 0. When it is still at rest, that means v at time 0 is also 0. Rest means no velocity. Find its location, so we want location when its velocity is 4 meters, so when v is 4 meters. So previously we have seen that x is a function of time. So we had x as a function of time. X was x naught plus v naught t plus half ax t square, and v was v naught plus a x t. And we can use these two equations to address the question. So what we can do in that case is we assume v equals 4 meters here, then v naught is 0, ax is given, then we can find time. Then if we insert that time into this equation, we get x. But I'm not gonna use these two equations today. It's lengthy for this particular problem. I can do another smarter way. So I know dvx divided by dt is equal to ax. That's how it is defined. Now I will write a dx divided by dx here. So this basically is 1. So I'm just multiplying 1 by this. Now I will replace dt and dx. So I will write dx divided by dt, dvx divided by dx. So I just swap the location of these two and nothing changed. So it's still equal to ax. Note that dx over dt is the definition of vx. So therefore this equation is simply vx dvx divided by dx equals ax. Now I can bring dx up, so therefore vx dvx equals ax dx. Now I can integrate. So vx square half from v naught to v equals ax x from x naught to x. Therefore half v square minus v naught square equals ax. And I could do this integration this way because a is constant. It's because we are doing a constant acceleration motion. X minus x naught. So here is another equation that I can memorize and use whenever x is asked in terms of velocity, not time. So now let's see what x is at v equals 4. Now I have half v is 4 meters. Sorry, it should be 4 meters per second. So it's 4 meters to power 2, 16 meters square second square, minus v naught is 0, equals ax 3 meters per second square. X, I don't know, I need x, minus x naught is 0. Therefore 16 divided by 2 is 8 meters square second square, equals 3x meters second square. I can cancel the second squares here, one of the meters from the two sides. Therefore x equals 8 divided by 3 meters. And that's it.
Thanks for watching. Please subscribe to support my channel. If you have any question or comment, please send me an email at open.physics.project@gmail.com. Thank you.